You guys, so this is a video going over how to find or use these triangle rules. The retake is is tomorrow. Okay, so first let's start with law of sines and cosines. When do we use law of sines and law of cosines? When we're trying to find missing sides or missing angles. Okay, the law of cosines, does anybody remember when is that useful? Side, 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 all the sides, or side, angle, side. Okay? Law of cosines is useful for, law of sines is useful for angle, side, angle, and angle, angle, side. Okay? You can also use it for ASS, but that's the ambiguous case because there could be more than one answer and you have to be smart about knowing which one's the right answer or not. Okay? Because remember, ASS does not guarantee a congruent triangle. So there's two triangles that can have the same angle side, and so we cannot trust that this is going to be the triangle. Anyway, so just be careful with ASS. In general, use SSS and SAS, use law of cosines. ASA and AAS, use law of sines. Okay? So all the even ones are just a repeat of the question before it. Okay? And so we're just going to do the odd ones as examples, and you could do the even ones on your own if you want extra practice. The answers are on the side. Okay? ASS being ambiguous, basically, it doesn't guarantee a congruent triangle, and so congruent triangles, and so basically be careful. Refer to my previous video if you want a more detailed explanation. Okay. All right. So you know what? I'm just going to go ahead and try to lecture, although it's really hard for me to lecture without asking questions, but I'm going to try. Okay. So, number one, I'm going to first figure out what I have. I have two sides and an included angle. So that tells me that this is an SAS kind of situation, and I know that SAS I use law of cosines. Okay? I'm going to use cosines on this example. Now, for law of cosines, I like to refer to my handy-dandy flip book that I've kept neatly in my, what's that called? Notebook? Thank you. Oh yeah, that's where it went. Okay, and law of cosines, thank you, is c squared equals a squared plus b squared minus, mind you, some people thought it was plus, and there is a 2 there, unlike some people thought, minus 2ab times cosine of angle C. The key is that this angle C is across from this side C. It doesn't have to be C, A, and B. We can say a squared equals c squared plus b squared minus 2cb times cosine of A, long as this angle A is across from that side B. We could similarly say b squared equals c squared plus a squared minus 2ac cosine B. Because you know what? Even though it's like the Pythagorean theorem, it's not, because this is not a right triangle, so we don't really have a hypotenuse. So any of them could be the C, any of them could be the A, any of them could be the B. The reason I say that is, okay, let's write. Okay, we have angle X, Y, and Z, right? That means this angle, this side across is little side X. The 10, which is across from the angle Z, is little side Z. And the 17 is little side Y. Do you guys agree? All right. Cool. We're all on board. Now, what is the formula then? Well, they're asking me, depends on what they want you to find. They want you to find YZ. What is that? That's my X. That's the side I'm looking for. So and I know the angle across from it. So I might as well set it up like this. X squared equals y squared plus z squared minus 2yz cosine of which one?
X.
Big X. Very good. Okay.
I have a question about the law of sines. So the law of sines works with every other triangle, or?
It works with angle, side angle, AAS. I can't say it works with every other. But kind of, yeah. Yeah. I don't know.
I can't say it.
Yeah. I'm just going to say IDK on that one. Okay? Test it out. Okay, so x squared equals 17 squared plus 100 minus 2 times, times cosine of 25. I plugged in everything that I know. The only thing I'm missing is my x. Yes?
For the YZ, you only use the side that.
Yes. Well, not always, but I'm saying YZ because the formula is always y squared plus z squared minus 2 times these two multiplied together. Now, the reason that... Okay, sorry, what's your question?
Why use YZ instead of using something else?
Like L and M? Because
No, I mean YZ instead of using the other.
instead of saying like X and Y,
Yeah.
because it's always one side squared equals the other side squared plus the other side squared minus 2 times these two sides multiplied times the included
But
angle.
why is it those two sides?
But since I know this angle, okay, since I know this angle, then I need to put that angle here. But then I need to put the side that's across from the angle on the other side. And so since I know 25, I know I'm going to put 25 here, but I need to put whatever side's across from the 25. What's across from the 25? The x. So that means the x gets to go here. Okay? So if you're kind of confused about that, when you see the next example that's a little different, see if that changes anything for you. So I'm just going to simplify. So x squared equals 289 plus, oh, I already did 100 here, 100 minus 340 times cosine of 25. Now, can we add 289 and 100? Totally. Okay, I said it like that on purpose. 389 minus 340 times cosine of 25. Can I subtract 389 minus 340?
No.
Why not?
Because that's not the
You have to
entire
multiply cosine of 25 first because you multiply before you subtract. So, okay, 340 times cosine of 25, if you have a calculator, why don't you go ahead and do that. 340 times cosine of 25 is 308.1446 ... I'm just going to put ... okay? Now can I subtract? Yes. And I'm going to get 80.85535 ... Okay, and I'm not going to round off early, because if I round off early, it's like playing telephone, and at the end you're going to get the wrong message, an inaccurate, a rounding error. Is that my answer? Is x 80? Why not?
81.
Square root. Okay, so the square root of that on your calculator is, oops, it's 8 point something, but with sides, I need what level of accuracy? 3 decimal places after the point. Okay, so 991. Do I keep the 1 or bump it up?
Bump it up.
Bump it up. Okay, so 8.992. Is it miles or miles squared? Is it area?
No.
No, it's length. We're just finding x. So 8.99, which makes sense. If this is 10, does this seem reasonable that this would be 8.9?
Yeah.
Yeah. So we're good.
You're eyeballing it.
That's true. But no, but I'm also using the fact that this is 25 degrees and, you know.
But you said it makes sense, you know.
Yeah.
Hey, that's eyeballing.
No. Making sense. Yes.
Hey. Just keep it to yourself.
Questions? All right. Okay, we got to move faster because in every class I'm like not getting through. Okay. So okay. All right. Just keep going faster and faster. Okay, so they asked us to find angle C. But what do I know? We have all the sides. So this is SSS. What rule do you use for SSS? Law of cosines again. But what's going to be different this time?
You don't have an angle.
This time I'm looking for the angle. So these two are law of cosine problems. Okay, so all right. So I'm looking for my angle C. So that's convenient. So cosine of C. We're doing number 3. That means on the opposite side, Jay, what do I need to have? C squared, right? Equals a squared plus b squared minus 2ab cosine of angle C. Okay, let's plug in what we know. Do we know what C is? Which side is C, guys?
11.
11 squared equals
17 squared plus 10 squared minus 2
okay, it needs to be quieter over there in Abraham's section. So 121 equals 289 plus 100 minus 340 cosine C. I'm going to add them and subtract them from both sides, okay? I'm just going to...
Cosine of C is going to be 11, right?
No. So 121 equals 389 minus 340 cosine C. Can I subtract 289 minus 340? No, I have to do what?
Cosine. Oh,
Divide?
you have to divide.
Add? Subtract 389 on both sides. So then I'm going to get negative, what is that? 121 minus 389 is negative 268 equals negative 340 times cosine C. What should I do now? Negative 3. What's a negative divided by a negative? Positive. So I'm going to get positive. I'm not even worried about reducing that fraction. Okay? Because cosine, so did I find my C? What happened to the C though? It got cosine. So how do I uncosine it? Arc sine. Arc cosine. Both sides. If I take a C and I cosine it and then I uncosine it, what happens? They undo each other. You get C. Alright? So C equals the inverse cosine of 268 over 340, which should be 37.97 something. Make sure you're in degree mode. Make sure it's positive. Now for angles, what point accuracy do I need? Just a tenth. No, for angles it's just a tenth. So it's 0.9. Do I keep the 9 or bump it up? Bump it up to a 0, so it's going to be 38.0. Yes? No, because sides round to the third. Oh, they did? Okay, well, that's true. Thank you. But we're going to cross that out because we're going to do what the book said. Okay. All right. So.
Wait, Miss, can you leave it a little bit up? I'm still trying to.
Yeah.
Good job.
Yes.
So like when it comes to functions like cosine, sine, those are functions. Like what order of like if we were like look at them in order of operations, what order do they contribute? Which part?
No, functions employ the order of operations. It's not a separate operation.
But like if you have like function of x plus g of x divided by that.
Same. You have to use order of operations on the functions. So if it's like, if it's f of x plus g of x times h of x, I have to multiply these two functions first and then add the other function. Okay, is that your question? Yeah. Okay, now let's talk about law of sines. I'm just gonna do one whole. Yeah, let's do one law of sines example. Notice, what do we have here? We have angle, side. What do we have here? Oh, this is interesting. It's angle, side. I'm going to see clear of that one. I have angle, side. Alright? So we're going to use law of sines on those guys. So these are law of sines. Okay, so let's go ahead and do number 6. Okay? Yes, ma'am. No, we only have 5 minutes or 8 minutes. Okay, so if you have angle, side, we're going to use law of sines. They asked us to find KP though. So I'm going to call this my X. Okay? So I'm missing a side. So how should I set it up, you guys? I'm going to go back to my handy dandy thingamabob and know that that's what the law of sines is from my flip book. So I'm going to say the sine of 115 degrees over what? X, because X is across, is equal to sine of 46 over what?
31.
Is that 31?
Yes.
Miss, I was going to say, why don't we just find the third angle? So then it could be a lot easier on us when we're...
You don't need it. You can, but you don't need it for this problem. Because you don't, if you find this angle, but you don't know this side, so how is that going to help you for law of sines? Right? Okay, so now we're just going to cross multiply. So 31 times sine 115 equals x times sine of 46. So to get x by itself, what should I do? Divide by sine of 46 on both sides. Oops. Sine of 46 on both sides. And so if that cancels out, I get x equals, and that's my answer. And you know, I feel like a kid like Pablo would just like to leave this. And that's okay if you don't have a calculator.
Yeah?
If you don't have a calculator. But then I also want to know if you can use the calculator. So sine of 115 divided by, you got to close those parentheses because they put the first parentheses for you, but they don't put the next one for you. So if I leave it like this, is that going to be the right answer? Why not?
Because it gets the whole.
This is going to tell me to do sine of 115 divided by something else, and I don't want to do that. So I got to close that parentheses by inserting it, and then I'll get 39.1 degrees. Oh no, it's not degrees.
Kilometers.
0,
Wait,
5, 7.
when do you say triangle that big though?
In my shopping mall,
A building?
a building, yeah,
Weird
or
triangle building.
on Earth, the distance between me and Memphis. I don't know. No. Memphis.
Whoa.
Memphis.
You're stuck in Memphis.
Kilometers.
You're right. Okay. So, all right, there we go.
City, guys.
Okay, so is that okay? All right, let's look quickly at this one. Find the area. I go look at my handy dandy flip book, and the area of a non-right triangle is 1/2 A times B times the included angle, sine of included angle C. Okay. So the area is 1/2 15 times 15 times sine. So many people use cosine for this one, you guys. But that's just the wrong formula. That means you just didn't study. Okay, and then you just do that on your calculator and you get, what I get is 88.651 miles squared. Did you? Check your answers on the back. Okay. Abraham, can you calm down, please?
Yeah.
Okay. Tomorrow you're also going to have 30, 60, 90, 45, 45, 90 triangles. So make sure you can do all of these, okay, on your retake. Should we try a few? Oh yeah, we have 4 minutes. Okay, this is easy. Okay. We only have 4 minutes. I don't have time to turn off the AC. Okay, let's look at 6. Okay, let's start with 5 and then move to 6. Okay, Okay, look, this is my short leg, which is my home base. If my home base is 3, how much is my hypotenuse? Double. How much is my long leg? 3 rad 3. Okay? By the way, all of these problems build up. So number 6, this is my home base. So how much is my hypotenuse? Just double that. If you double it, what do you get? No. The only thing you do is multiply this by 2 over 1. So you don't multiply the rad 3 by 2 and the 2 and the, it's just 4 rad 3 over 3. Get me? And then for y, you're going to get 2 rad 3 over 3 times rad 3. So it's going to be 2 times, what's rad 3 times rad 3?
3.
Okay. Okay. All right. What about number 7? They gave me the hypotenuse. So how do I go back to my home base? Divide. Oh, that's easy. Okay. Well, what if, look at number 8. They gave me a hypotenuse with some weird stuff in it. I still have to do what to get to my home base? Divide by 2. And so all I do is 2 rad 6 divided by 2, which is? Rad 6. And what's rad 6 times rad 3?
Rad 18.
But 18 is 3 times 3 times 2. So who comes out of the house? 3 rad 2. Okay? All right. You tell me. I want this answer, the exact answer. Okay? The homework is to study for your retakes by doing these 2 worksheets. Okay, so let's look at number 8. I mean 11. What kind of triangle is this? 45, 45, 90. What side did they give me? The hypotenuse. So to get back to my short leg, my leg, I have to divide by rad 2. Okay, so that means this is the same. This is 8 over rad 2. But then this is the what? This is the long leg. How do I get from the long leg to the short leg? Divide by rad 3, which is 8 over rad 6. How do I get from the home base to the hypotenuse?
Multiply by 2.
Double it. So it's going to be 16 over rad 6. But what's wrong with that? Get rid of the radical in the denominator by rationalizing it. So I'm going to get 16 rad 6 over 6. Does that reduce? This is some crazy stuff. By what?
2.
2 over 2. So that's 8 rad 6 over 3. And my journey is complete. Thank you. I take a bow. Okay? Perfect timing. Okay, you guys, give me 5-minute break. Exit the room, and you can come back if you need tutoring. Okay? You guys can all go.
Why do you get -2?
Because I was being nice.
Did you ever put these grades up?
Yeah, just